I'll just quickly introduce myself. Yeah, I'm William Lee. I've been a Scala developer for 7 years, 2 of which now I've worked at IMG. Previously, I've worked in the public sector with HMRC and in finance for a smaller fintech company called Pyram. Yeah, broadly speaking, I've been mainly an Akka Streams developer or Play developer when I was at HMRC, and then here, still following the same vein, but now moving on to the Scala Framework. So I work in a department of IMG called DDE, which is the Digital Data Exchange. What we do is we collect data from our various providers, so that's ATP, PGA, WTT, CEV, whoever it is, and we basically move it into a standardized format for IMG and produce that for our customers. We did, like I said, I've mentioned a whole load of providers, so we do tennis is ATP, MMA, golf, volleyball, table tennis, basketball. The data we provide comes in 2 flavors, static and live. Static data is the tournaments, the matches, the teams, the players, etc. Things that won't basically change over the lifetime of a tournament. And the live data is each individual event, like everything that happens within the event. So when the match kicks off, when someone scores, if somebody gets fouled, anything like that. So the static ingest that we have is quite simple. It's just a HTTP endpoint, receives it, stores in the database. Plain and simple. The exciting part of what we do comes in live. So here's our current live architecture, built of 3 services, built in Akka and Scala. Live ingest does exactly what it says on the tin, takes the data in the format from the provider, moves it into like an internal IMG format for ourselves to use for internal purposes. And then those packets are broadcast to the various instances of FeedBanks. FeedBank is our service where we do transformation and enrichment. And then we move into the outbound formats, which is what we'll put into the next service along, brought again via a broadcast to EventStreams v2. And that's where WebSockets are generated for our clients to receive their live data. Each service communicates between themselves using TCP. So the reason for that is for the speed. So we need to provide the data fast. And each service stores its state, well, so each service, mostly FeedBank, stores state in memory. So that also helps with the speed. And that's it for the current architecture. Moving on to our new architecture. The reason we're moving to a new architecture is because our current architecture has a couple of flaws, namely that broadcast mechanism. While that broadcast mechanism does provide like speed and high availability data. The thing is, when you provide data across a broadcast, if there's an awful lot, it can potentially die in every instance because they will run out of memory, basically. So this new situation, it hasn't happened in pod, thankfully, but yeah, we have seen it in load tests, but we haven't hit that capacity. Moving on to this new architecture. Live ingest runs same way as it did before. Takes from provider, but instead it output that data in the IMG internal format and onto a Kafka topic rather than broadcasting. So we have 1 place to send it to rather than 3. Then what we do is we have the stream service, which is the feedback replacement. And what that does exists within that outer box there is a consumer group. So each instance of that provides, listens to a partition, takes the matches from those partitions, provides them and pushes them onto the outbound Kafka topic. And also, while this is going on, state, rather than being stored in memory in the applications, is stored within a Redis server, so it can be looked at later. And it's the same sort of thing, but rather than storing redundantly 3 times, it stores it 1 time. We all know what you need. And then provides also a Redis stream for the WebSockets, which our customers will consume as well. And the enrichment topics there on Kafka, they'll be used by customers later on, but primarily right now they're used by internal consumers. So what I'll do now is I'll go over some core differences, key differences between how we've done things in Scala with the Akka framework and how we're doing things with Zio. So if you just bear with me 1 second, I'll just get the screens open. And we'll start off with no, not that one, just a quick demo of the service running. Right. So I've got everything up all running now beforehand. So what I'll do, I'll start this consume a producer. If this goes well, yeah. So we've got a test file here. I'll just Command A and see. on there. So that's now gone through our what's it called, our DD stream service, which does the Kafka implementation and Redis. So now I'll just go over to Redis Insight. So we've got that browse. So what you see now is the state of it, so, which is that right now, because there's no enrichment data for this thing locally. It's just the previously seen sequence number. So this is how we avoid duplication. So we basically just say, hey, Redis, what's the current state? What's the last seen sequence number? And if the new packet comes in with a higher sequence number, then good or fine. But if it's less than or equal to that number there, then it's a duplicate. Also, then there is the packets. I think I'll have to go over to streams. And you see it there. So the packet structure might be slightly different because there is a very slight transformation in feedback in streams that will actually take something what would normally take the enrichment data of, say, like a player ID and replace it with like a player name as well. So, but that's effectively the format you get there, and then that will also appear in the outbound topic. Okay, so now moving on to some of the key differences. I'll start with the Active Service. So one of the main differences when we were building this is we had an issue where we knew everything that we needed to build. So every stage we had there was reconstruction, just in case there was a packet missing because of like connection intermittency. There was then deduplication, enrichment, transformation, and then output onto event streams v2. So all of that is kind of built up here with all of this. So we kind of hand cranked everything in that old framework and built it up like this. So it was kind of hard coded how it kind of goes. So you got the reconstructor, deduplicator, synchronization. Oh yeah, synchronization is one thing we do as well. So if a new instance of feedback comes up, it needs to synchronize with the other existing ones to make sure it's up to date. And that's that. Pretty much a whole big file like that, just to wire everything together. And like I said, everything is kind of hardwired into one stream, which actually is this, and that's all that. In Zio, what we've kind of done now, knowing some of the things that happened before and we weren't quite a big fan of, is we've moved to more of a phase of to make everything more pluggable. So here is effectively one feed in Zio. So we set up what's called a stream runner. That basically is like the two endpoints in Kafka, which is the consumption and then the production layer, or production, consumer and producer, beg your pardon. And we give it all a list of everything it needs. So the configuration, obviously, you want to configure what it's connecting to, and then the producer and the consumer. I've set these to local now, for the demo, and then you see here the effect. So again, just provide any of its dependencies, but it's just a little thing. The main thing you'll see that when we want to build a stream up is something like this, the pipeline. So this pipeline is more plug and playable, because what we can actually do, if say we don't ever want to use enrichment, we can just comment it out or just remove it altogether. So it's more plug and playable compared to beforehand, and it's all defined in the nice way, the nice syntax of Zio streams, where you just use the treble arrows and it just one into the other, easy peasy. That's one thing we definitely liked about that. I think we then moved on to I haven't spoken about the provide. So provide. This is one thing that's good about Zio, is when you use the service pattern, you can easily use the .provide function on Zios, where you can give it the requirements you need, and it gives you a really, really good DI layer, also dependency injection. So for now, what we normally do, you might have seen the commented out bits where I had the live layers and then the local layers. So this makes things a lot more testable. It also means that, for example, I provide an interface or a trait there with just the Zio that it needs to run. So the behavior is for deduplication. I can just, well, not deduplication, what's one that has a bit of behavior in it? State storage. So state storage for local testing, I can just provide like an in-memory storage, like a map of something. And then, when I want to build it into the real application, use the live layer, which actually backs onto Redis, but it uses the same interface every time, so you can be sure that it works like that. That's one major thing we liked about using Zio. I think that's enough for the demo, so I'll go back to the slides. There we go. that's that. I think now it's mostly for summary. So why Zio? Akka moving to a paid model, so we wanted something that was free, and Zio, so that's widely advertised in the Scala industry. I think pretty much everywhere else I've worked, there's always been someone who's wanted to chew my ear off about Zio and how great it is. So yeah, we've given it a go, and we've been very impressed with it. It has everything that we needed. So Zio Kafka, test framework, and JSON serialization. Pretty much almost everything we needed. You know, there's only like one slight thing we had to do, but it was easy enough to kind of like weave it in there from non-Zio to Zio, which was really good. Yeah, and that's that one. So what I personally like about it, I personally like the fact that each function signature is defined in Zio REA, so you know what requirements you need, so that allows you to build the provide list easily. The errors, so you can define what kind of errors you want. So normally you could just go really broad and say, oh, just throw some kind of exception, but no, this allows you to define your own error types and say, like, you know, we use this a lot in the actual stream effect, which is we say we have a feed error as a main super type for a trait, and then we have duplication error, enrichment error. So we can very easily make our own like specific error types and say what's happened, and we kind of know exactly what stage something went wrong, and that was one thing we liked about that. And having just the A bit, you know, it's nice not having everything. It's like one thing's a feature of an option of something. Yeah, I feel like I think it's a bit more consistent when you put within the bounds of Zio. The service pattern, yeah, that thing is really good. Just mostly on the dependency injection thing, so we don't ever have to write anything like I showed you with the old feedback service, a giant class just effectively to wire everything together. I mean, we probably could have used another DI mechanism, but it wasn't the way the framework was kind of written. And Zio test framework, I've kind of given this one a bit of an honourable mention because I don't know about any of you, but I've used like Scala test exclusively for so many years that when moving to Zio framework now, kind of how newish it kind of is. I was thinking, oh, is this test framework going to be mature enough to handle all requirements? Yeah, absolutely, it was. It was, you know, had all the assertions it needed. You can do nice things as well with test aspects in Zio, like, you know, if you have a flaky test because you've got like a database and you might be working on the same table there, you can use flaky, like a dot flaky, and you can basically give a number of retries to say, yeah, it works, because you know it works. If you run it in isolation and you know it works 100% of the time, you can kind of say, okay, it's flaky, give it a couple of tries. One of those nice little things. Yeah, that's the main thing. So I think, yeah, thank you all for listening, and does anyone have any questions? Yes. That's some sort of question. Somewhere around. Right. Yeah. Go on. Yep.
Yeah, I was curious about like the latency and throughput of the system. Did you notice any changes?
No,
did you have to do like extra stuff to to get to the kind of performance you need?
That's the kind of thing we're still testing actually at the minute. So yeah, I could tell you if I had the answer, but right now we're still in the middle of testing. This new architecture is really brand new, so we're still testing that.
Okay, and I guess the second question that I've seen that the ZStream data type, it behaves a bit different from what I'm used to in the Java world from the reactive stream stuff. So in the sense that if there is an error of any sort, it will just stop. So for instance, assuming you have you want to simulate like a stream in Kafka and there's a network error or any sort of problems, and you just like to maybe ignore it or kind of retry it and just continue doing that. How do you do this?
So our stream is kind of interesting. So that packet stream you saw there is kind of like for one packet. We use the stream DSL because it could be, because our packets can be a case with reconstruction anyway. It goes from one packet into many as it comes through. But normally you normally see a 1-to-1 ratio. But the stream's definition was it makes it easy to define all the plug and playable parts. So what happens if whenever there's a stream error happening in the stream runner, because that's where this is all encapsulated, errors that come out of that are picked up, and what we do is we log the error and commit the offset anyway to just keep everything moving on, because we don't want a situation where something goes wrong and everything has to stop until you resolve the error. That's quite catastrophic in our world. So yeah, we basically make sure that an error is, you know, people know what happened. So if there's a duplicate error, enrichment error, or something else, we know something's gone wrong. But we make people aware of it through alerts. but the rest of the world can still go on, because it could just be a freaking accident that gone along and the rest of the stream's fine.
But you're basically restarting the stream.
Not quite restarting the stream. I think that for that packet, that stream is just gone dead. But the stream, the consumer, yeah, that still lives. Basically, that doesn't fail over and die. It just yeah, it keeps going. Except we have like a catch statement basically to say, yeah, catch the error and just commit the offset, and don't do anything else.
What challenges you have faced when you're migrating your code from Akka to Zio, and how much legacy code could be reused in Zio, or we have to change all architecture and everything?
So the main difficulty with from Akka to Zio was basically learning how Zio does things. So their way of doing things is very different. You have to. I'd say it's a bit more rigid than Akka, basically. So when you want to define like, so for example, Zio effects, and it needs to have requirements. It's very much you are going down their service pattern, building up your layers, and using it. But when you've got used to that kind of pattern, that everything kind of becomes kind of easy actually. And like I said, you get the more plug and playable elements to your application for like local testing and using live data, and you don't have to change actual kind of bits of code, I suppose, or you can easily write a dummy in the same interface as you can write the live thing in that same interface. As far as reusing certain things, yes, we can do. So a lot of the main bulk of our codec work between the packets, like from our external into internal, how we transform that, it was written in one kind of framework. Also like spray JSON, we just had to kind of just do the models again and write. So just use the Zio packet structure, say for Zio JSON, the codec gen. For the most part, some things had to be done, but had to change in some places. But actually, as far as like the actual behavior of some things as well, yeah, you could absolutely reuse it again. The transformation block we have for that stuff I showed you there, which was multi-sports, that was more or less the same sort of behavior. It's just trying to transplant, maybe just an odd tweak just for Zio, but yeah, actually that sort of thing was very easy. The logical stuff was very much the same, for like deduplication, enrichment, etc. Very much the same. Yes.
How have you found Zio to be for integration tests? Because that is of course usually tricky with concurrency and many dependencies, etc.
Yeah. So integration tests has kind of worked okay. So how I've kind of done those is to have like a local Docker Compose stack for all these things we need to integrate with, so Kafka and Redis. You pretty much, if you were using the live one that points it to Redis or the local ones, beg your pardon, so they point to like local hosts. Yeah, actually, well, for the most part, pretty simple. You can use the same like Zio tests, as if almost like you're writing unit tests, with just the right layers that you need for local testing, and it works. Obviously, because I think some of the tests actually kind of run concurrently. There was like some clashes, but if you then ran them on their own, they'd be like 100% of the time would actually pass. But then just because of the test suites were running at the same time, you might get some state in Redis changed before you get like something was deleted beforehand. So you just literally put test aspect dot flaky and let it run a couple of times until it actually runs. It's a bit cheap, but it works.
Yeah. Well, you had the same issue in Akka always, but you didn't have the flaky solution.
Yeah. Yeah. I think that was probably eventually, but it was a bit funny.
One question,
yeah.
Yeah. So how deep into Akka like were you with the old architecture? Like was it like just Akka HTTP and streams, or like were any bespoke actors, or like Akka clustering, Akka persistence?
Nah, pretty much just Akka streams and Akka HTTP, very much so. The streams and some elements got a bit more complicated, like how they were done, to like splitting and filtering, doing various because it was all doing multiple things. So we had like the actual straight upstream for the data flow, and you had things where they'd break off and do some like RabbitMQ notifications and things like that. But yeah, for the most part, it was simply just Akka HTTP, and at the end for the WebSockets end, and for the most part, yeah, the rest of it was all either like like a TCP server, but Akka had one of them, luckily, which was nice because we actually had to kind of build on a bit more from scratch in Zio, which was a bit of a challenge. But yeah, like I said, mostly just streams and HTTP. No like massively custom actors. I don't think.
So is like zero should be like a good alternative? Like, is it mature enough? Or?
Yeah, definitely. If you're just doing like streams, where you've kind of got like map, and things like usually map maybe fold as well. Most of the same like things you can do in Akka streams, you can pretty much do in Zio as well. Maybe not some of the more advanced stuff, but you know, if you like basic transformations, definitely we found that have been very much you get the same sort of behavior. You can do like you can even do stateful maps as well. Like it's like map accumulate rather than like map concat or something.
Did you consider paying for license, or you wanted to change the architecture anyway, and just like was this nice kick to make it happen?
This was the Akka licensing was a nice kick to make this happen. I don't think we had too much thought about it at the time, but considering how much of Akka we use in the pricing, we were like, not paying that. Absolutely not.
Thank you.
How was the learning curve in your team adopting Zio? Because it is a bit of a complicated framework when you're first using it.
Yeah, so initially it's quite like right up, but then like once you kind of get used to it, it kind of comes down quite nicely. So it's I'd say probably took me about a couple of weeks really to kind of get used to the idea, but you kind of just write examples, anyway, and stick to a few certain principles, and generally you get it quite nicely. So Zyverge have quite a lot of YouTube videos anyway on how they build certain things, especially for the service pattern. That what they kind of say is like for the traits when you're building your service, try and make sure the Zio has like no requirements at that point. And then when you want to build the actual implementation class underneath it, that's kind of when you use the constructor to add your requirements in. So if you need a Redis backend, you can put that in there in the constructor of the case class. And then you build the layer in the middle in the companion object of the traits, and you just say that's the requirement. So requirement Redis, and there's like service with Zio. I'll actually kind of show you if I can. Where's a good example of this? Storage. Back to storage, right? Okay. So that's basically the first half of it. There's the interface. Just have a task. Task is kind of like the analogy of a future in Zio. So has no requirements, will fail with an exception, and return, in this case, a unit. And so first part of the thing is just to define what you want as the layer. So our layer is a Redis. You take a requirement of a Redis client to connect to Redis, and it'll give you a package storage interface, which will give you the store function. And you literally, especially if you're using case classes, you can just do zlayer.from function apply, and I've put these are simple like function requirements here, just because they don't need to go in the Zio R requirement because they're so trivial. It's just a duration and a max length. But then what we do is you have the class here, where you have the constructor, so the client, the TTL, the max length. Here's some of the like private stuff. Here's just a connecting. So you only want to do that for a little bit, so that's what the scoping is for. But the main meat of it is here. Just using store, and you set up all the things you want to do. And like I said, this is probably the funny one actually, because this is the one I said you might need to. Some things aren't quite Zio ready yet. This is one of those instances where we had to use a Java library and then wrap it into something into Zio. So luckily Zio has from completion stage, which allows you to kind of do that for all the asynchronous stuff. So yeah, that's basically just build your implementation like that. But when you actually go to use it, all you'll ever really see is just everything will be exposed at the interface level, pretty much. So at that point, when you're using your code, you could then say, okay, I want to use an in-memory package storage. You just change the layer from layer.redis to in-memory, and on the code will be exactly the same, pretty much. But just things won't be talking to Redis. It'll just be storing it in a map. And that's the kind of good thing that you can do with Zio. Easy peasy. When you learn how to do that service pattern, that's kind of when things really get a lot easier. That's a bit of a ramble, but I hope that answered your question. Yes.
And what version of Zio do you use? Is it 1 or 2?
Zio 2.
Zio 2.
Yeah, went straight to that one.
What do you use any security libraries for Zio HTTP, or how do you manage visualization?
We haven't got to that point of using HTTP yet, so we've kind of got, I think, with Kafka, and because we use Confluent, we use their system for the authentication, so they have like the user credentials that you get, and then that's how we connect to Kafka. So that's managed kind of externally on that end for us. But yeah, we haven't got to the point of using Zio HTTP just yet. We haven't built that WebSocket replacement as of yet. That's to be done.
Because I personally found that some libraries were not migrated from Zio 1 to Zio 2, and then I also tried to find authentication, some maybe standard authentication library for Zio HTTP. I didn't manage to find something.
Okay, that's one thing we'll have to look out for. Thanks for the heads up. Yes.
Yeah. A question on your code organization. Do you guys use like a layer architecture with core business logic, not depending on Zio types, and then a thin layer of Zio types? How was it organized internally?
I think internally, so I think what we had to do is kind of it's still kind of dependent on Zio. Unfortunately, the core business logic, most of it, it can be kind of done without being tied to Zio. I think enrichment and deduplication was probably the main thing for it. But the kind of way we built it with the state, while it's progressing through the stream, that's it uses Z state. So I think we kind of actually to answer your question, I think we kind of weave it in with Zio, but it's the core principal idea is it's the same between Akka and Zio. It's just we had to marry it together differently depending on the framework. Any other questions? Going once? Going twice? Yes?
What's the thing that you hate about Zio?
One thing I hate about Zio, I'll say the learning curve, because I spent the first few weeks just swearing my head off, going, why isn't this work like this? Why isn't it like that? Yeah, it can be quite painful at first, but when you get used to it, it's very good. That's the main thing.
Regarding the learning curve, what you think would be simpler, Akka, HTTP, Zio, or Cats Effect?
Akka HTTP would probably be the simpler one, I think. I might be biased because I worked for it for so many years, but I just picked it up and it was quite there. Cats Effect, I haven't tried Cats Effect, so I can't comment on that. But yeah, I think between Akka HTTP and Zio, maybe Akka HTTP still probably beats it out for being simpler. Same again. Going once. Going twice. That's it. Thank you very much for listening.